Welcome to The Explainer. Today, we're diving headfirst into one of the biggest puzzles in all of physics, a mystery that has the scientists themselves totally divided. So let's just start with this pretty provocative idea, which is actually based on a real survey of physicists. It seems the very people who study reality can't quite agree on what the biggest problems even are. Get this. A 2016 poll shows the community is fundamentally split right down the middle. And what's really stunning is that almost a third of them, 29%, believe the problem was solved by this one concept called decoherence. So, what is decoherence? And why are so many people convinced it's the answer while so many others aren't buying it? Let's investigate. Okay, first things first. Before we can talk about the solution, we have to understand the central crime in this quantum mystery, what we call the measurement problem. All right, so let's get into it. According to quantum mechanics, a tiny particle, say an electron, can be spinning both up and down at the exact same time. It exists in this kind of ghostly blend of all the possibilities. But the very instant we try to measure it, that weird blend just vanishes, and it's forced to choose a single reality. All of a sudden, it's either spin up or it's spin down. And that, in a nutshell, is the measurement problem. How does nature take this wave of countless possibilities and just collapse it into one single concrete reality? What makes it pick one over all the others? Now, for a whole lot of physicists, the answer seems pretty clear. They point to a prime suspect that they believe explains everything, a process called decoherence. The idea behind it is actually brilliantly simple. You see, no quantum system is ever truly alone. It's constantly being nudged and bumped and kind of measured by everything around it. Air molecules, photons of light, even the detector you built to observe it. The key idea here is that all this constant chatter with the environment is what actually strips away all that quantum weirdness. So how exactly does a little bit of environmental noise manage to erase something as fundamental as quantum behavior? You can think of coherence as the secret sauce for all the quantum magic. It's this hidden property of a particle's wave function, something called its phase. And it's this special mathematical property that holds all the different possibilities together in one neat, weird superposition. The whole process is kind of like death by a thousand cuts. Every single tiny, random kick from the outside world messes with that secret phase information just a little bit. But over tiny fractions of a second, all those random shifts pile up, and the original clean coherence just gets completely scrambled and destroyed. I know, it sounds a little counterintuitive, right? How could a bunch of random noise lead to a clear, classical result? Well, there's a fantastic analogy that really makes it all click into place. So let's imagine that every little kick from the environment can be represented as a random point on a circle, somewhere in this abstract mathematical space. So one bump puts a point here, another one puts a point over there, just all over the edge. But here's the amazing part. When you average out all of those random positions, the result isn't on the circle at all. It's at the dead center, 0. And that is exactly what happens to the phase information that makes a superposition possible. It literally gets averaged into nothingness. So decoherence seems to perfectly explain why all the quantum weirdness vanishes and why our world looks so normal and classical. Case closed, right? Well, not exactly. This is where the big twist comes in. And this slide really nails the gap in the explanation. Decoherence is super powerful, but it only takes us part of the way. It turns that weird quantum superposition into a set of normal classical probabilities. It's like it turns the situation into a coin that's about to be flipped. It tells us, okay, there's a 50-50 chance of heads or tails, but it does not explain how one of those probabilities becomes the single definite reality we actually see. It doesn't explain why the coin landed on heads. Okay, so let's try to bring this all together. What does all this actually mean for the world that we all live in? Make no mistake, decoherence is an incredibly important process. It's the reason our everyday world seems so solid and definite. It's why big things like you, me, or a cat are never in a spooky superposition of states. The constant interaction with the environment just makes sure of it. But, and this is a huge but, it only solves part of the mystery. It gets us right to the doorstep of reality by creating a simple set of odds. But it doesn't explain how nature actually steps through that door and makes a final, irreversible choice. And that leaves us with the final and, frankly, the biggest question of them all.
That question, the one that turns all those maybes into a single concrete is, remains one of the deepest, most profound mysteries in all of science. Thanks so much for joining this explainer.